Okay, let's start our session today. The last part in this lesson, and it's the last lesson in our curriculum, it's talk about the third type of rocks. We said before, or you know, of course, there are three different types of rocks, which are, who can tell me? Juju or Lulu? There are three different types of rocks, which are? Yes, tell me.
Sedimentary rocks, stratic rocks, and igneous rocks.
Great. Sedimentary rocks, metamorphic rocks, igneous rocks, according to the way of its formation. Okay, what about the igneous rock today? Today we will talk about the magma and the difference between magma and lava. How come? First of all, according to the high temperature and the high pressure beneath or under the Earth's surface, there is molten metal, or there are many molten metals with very high temperature. According to the high temperature and the high pressure under the Earth, the metals which are found under Earth, we will find them as in molten state, like the molten chocolate, for example, in summer season. So these molten material or molten metals and the molten rocks under the Earth, we can call them magma. Again, so the magma is the very hot molten material. Very hot molten material, it's look like a heavy liquid formed from the melting of minerals under Earth due to the high temperature and the high pressure. Okay, so again, Lena, can you tell me again what is meant by magma?
It's very hot molten material formed from the melting of minerals which compose certain rocks in the Earth's interior.
Okay, great, well done. So the molten material from melting mineral under or beneath the Earth's surface, it's called the magma. Magma under the Earth's surface. But if there is a volcano erupts, what will happen? The magma will reach the surface of the Earth and it will turn to lava. So when it move or come out and reach the surface of the Earth, it will call the lava. So magma under Earth, lava above the Earth's surface. Okay, did you get the difference between the two? Magma and lava? Magma under Earth, lava on the Earth's surface. Okay, so the magma, the very molten metal, when they form under Earth, if they cool, they will cool very, very slowly due to the high temperature under Earth. So they will form a type of rock which is called the platonic rock. But first of all, let's read the lava definition. Lava, it's magma, but when it reaches Earth's surface. So if I draw a volcano right now under Earth, the molten material, it's well called magma. If the volcano erupts, the magma will reach the Earth's surface. So if it reaches the Earth's surface, it will call the lava. Okay? Did you get it?
Yes.
Great, well done. So let's talk right now about magma and lava when they cooled. But I wanted to ask you a question first. What do you think? The magma or lava will cool very quickly or cooled first? Magma or lava?
Lava.
Lava, why?
Because it's on the surface.
Excellent, because it reaches the surface, so it will lose the heat very, very quickly and cooled very quickly. So it will form a type of igneous rock, which is called the surface. Surface, and remember this name. Surface means it's formed on the surface of the Earth. So surface igneous rocks means when the lava reaches the Earth's surface, it will lose heat very quickly. It will cool very quickly. So it will form a type of igneous rock, which is called the surface igneous rock. Like the pumice rock, it's igneous surface rock. Okay? But what about the magma under Earth? If there is no volcano, or there are molten minerals and molten materials which are magma under the Earth's surface, it will cool too, but will cool very quickly or very slowly. Yes?
Slowly.
Because it's formed under the Earth, so it will cool, but very, very, very slowly. And it will form a type of igneous rock too, but it's called platonic rock, like the Gabru rock. So in the exam, if they asked you the Gabbro rock, it's a type of, who can complete it? Gabbro, it's a type of what? Platonic or surface igneous rock?
Platonic.
Platonic. Where are you, Lena? You didn't answer any question till yet. Lena.
I'm sorry, I'm here, but I didn't.
You didn't, what?
Yeah, I'm hearing you, but I
Okay, well done. So focus with me and stay with me too. Okay, so we have two types of igneous rock, which are platonic rock and surface. Surface, remember this word. Surface means it form on the surface of the earth. Platonic means interior. It will form but inside the earth, under the earth's surface, beneath the earth's surface. So platonic will cool very slowly under earth's surface or beneath earth's surface. While surface igneous rock, because it reaches the earth's surface, it will cool very, very, very quickly, and it will form the surface igneous rock. Look like what? We have an example here, pumice. It's a type of surface igneous rocks. But Gabbro, it's a type of platonic igneous rock. Platonic means formed beneath or under Earth's surface. How can we differentiate between the two types? As I told you, the magma will cool very slowly because it forms under the Earth's surface, beneath Earth's surface. So it will take longer time to be cooled and form another rock. But when it forms the platonic rock like the Gabbro rock, it will form it with large crystal. If I differentiate between the two types of rocks here, we can find it. It's a crystal. If we look at it's a crystal, it's formed like a large crystals. While here the pumice or the surface volcanic rock, it has small crystals. Why? Because it cooled very, very quickly. In a short period of time, it formed rock with small crystals. So the difference between the two types here, platonic rock formed beneath the Earth's surface, take its time, take longer time to be cooled, to cool very slowly, so it form a rock with large crystals. While in the other type of igneous rock, which is volcanic or surface igneous rock, the lava will reach the Earth's surface in short period of time. Short period of time, it will lose heat. It will cool very, very quickly. So it will form the surface igneous rock like pumice, and it will have a small crystal because it took short time to be cooled. Very quick. Okay, we have here the platonic igneous rock like granite, Gabbro, surface igneous rock like basalt, this black rock, and pumice. We have a question here. Lena, can you read it?
Yes, give reason it's possible to distinguish the crystals of granite by the naked eye, while that of basalt cannot be distinguished by the naked eye. Because the crystals of granite are large due to the slow cooling of magma, while the crystals of basalt are small due to the rapid cooling of lava.
Great, well done. So, as I told you before, let's draw something like a volcano. We said, Lena and Jana, tell me the molten material from the molten mineral under or beneath the earth, it's called magma or lava?
Magma.
Magma, great. But if it reaches the earth's surface, it will called?
Lava.
Lava, great, well done. Which one of them will cool very quickly? Magma or lava?
Lava.
Lava. Why? Because it reaches the earth. When it reaches the earth, it will lose the heat very quickly, very fast. So the lava quickly, it will be cooled very quickly and form a type of rock with small crystals because it takes short time to be cooled. It forms a rock very quickly because it loses heat and cooled very quickly. While here magma, it's under the earth or beneath the earth. There is a lot of temperature and pressure, so it will cool. It will form a rock too, but after long period of time, it will take a longer time. So it will cool, but very slowly take its time to form a type of rock, which is called the platonic, with large crystals. Okay, did you get it?
Yeah.
So this is the two types of igneous rocks. Plutonic rocks means under earth or beneath earth, and the volcanic or surface rock on the earth's surface. What is the integration here with the science of construction? We can use the rocks of all type in construction. Like in the first term, you took an information which told us they use the limestone to build the pyramids of Giza in Egypt and the Sphinx too. What about another new information in the second term? Taj Mahal in India. It's a famous palace in India from the famous one. And they used the marble to build the Taj Mahal in India. And we have here the last part of the lesson, which is the rock cycle. It's something similar to the water cycle in the last or the previous lesson. Who can tell me what is meant by water cycle, which you took it in the last lesson? Water cycle. Who can define it? Jana or Lina, water cycle in the previous lesson.
It's the process of water while moving, or maybe it starts with evaporation when the water changes into water vapor, and after that the other processes. So it describes the cycle of the water, how it.
Great, Lulu. So we can say the water cycle is the movement of water through Earth's system, or the change of water from one state to another, right?
Yes.
So the water can change from one state to another, as the rock cycle too. The rock cycle, the rock here can change from one type to another type. How come? Let me explain with example. If, for example, we have here this type of rock, which is igneous rock. The igneous rock here, I can see it. What will happen if there is a lot of rain or wind, heat from the sun will cause weathering? First of all, weathering. Who can tell me what is the meaning of weathering process? What is meant by weathering? Okay, Lina, yes, tell me.
It's the breaking down of rocks into small pieces.
Great, well done. And then there is another process after weathering, which is
erosion.
Okay, what is meant by erosion?
Erosion is when it moves after breaking down from to another place.
Great, well done. So when the rock break down into small pieces, break, it will be weathering. And after this, due to many factors, maybe wind, maybe water, maybe rain, maybe gravity, it will move from one place to another place, from one area to another area, which is erosion, like a journey. I called it the erosion like a journey, when the small pieces of rocks or sediment move from one place to another place. It's the erosion process. So when they move small pieces of rocks, a layer of sand, some fossil, and they form many layers above each other. So it will form another new types, which is the type of rock which contain of many layers. Who can tell me its name?
Sedimentary rock.
Sedimentary, excellent. So it was igneous. By weathering, then erosion, many layers of rocks and sand, fossils, they will be above each other over a million years of time. What will happen? They will compact together to form a new rock, which is sedimentary rock. Okay, what will happen to the sedimentary rock after it exposed to high temperature and high pressure? It will form another type, which is the rock which is formed metamorphic. Excellent, well done. Because the metamorphic rock, I said it's not a type or a specific type of rock. It's any type of rock. When it exposed to heat and the pressure, it will form a metamorphic. So it was igneous rock in the beginning. By weathering, erosion, deposition, and forming many layers above each other, it will form another type, change or transform into another type, which is sedimentary. Sedimentary rock, after it exposed to high temperature, high pressure, it will turn into another one, which is metamorphic rock. What will happen if the metamorphic rock exposed to water, wind, temperature, and they break down into small pieces? break down into small pieces, it will be, who can tell me? Weathering, erosion, deposition, form another layers to form another sedimentary rock. If I'm talking right now about the mineral beneath the earth, after exposed to high temperature, high pressure, they will be mold, like a molten metal, which is molten metal under the earth's surface. It's called, as I told you today, magma. Great, well done. When the magma cooled under the earth, it will form another rock, which is called igneous rock, plutonic rock. If the magma reaches earth's surface, it will called, it reaches earth's surface. Magma will be
igneous.
It will be a type of igneous, but first of all, it will turn into lava, and when it cools down very quickly, it will form an igneous rock too, which is surface igneous rock, or we can call it volcanic igneous rock. Okay, so the type of rock can change, can convert, can transform to another of rocks when it undergoes many processes like weathering, erosion, heat, pressure, melting, cooling. This is called rock cycle. So as you talked in the previous lesson about water cycle, like when the water changes from one state to another, the rock cycle too. It's a transformation of rock from one type to another. Okay, did you get it?
Yeah.
Okay, well done. The last part, I think you studied before in grade 4. Who can tell me? We called the plant or the green plant as producers. Why? Or autotrophic organisms. Why? Can tell us the reason. Okay, Lulu, tell me.
Because it makes its own food by the photosynthesis process.
Great. And this type of food, Lena, stored a type of energy which is called? You remember from the primary stages? Or Jana, any one of you?
Maybe glucose.
Can you repeat the question?
Okay, the food which the plant make it, or even the food which we eat, it gives us energy. What is the name of the energy that is stored inside the food?
Chemical energy.
Chemical energy. Excellent, well done. So first of all, in this part of the lesson, and it's the last part of it, it talk about the plant. The plant, first of all, they are autotrophic organisms or producer, because they can make their own food during the photosynthesis process. In photosynthesis process, they depend on what as the main source of energy? The plant depend on which source of energy? Sun. Great, well done, Lulu. So they will take the light energy from the sun to help them to make their food which is storing chemical energy. After the plant die over a million years, what will happen to the dead plant?
The plant will get decomposed.
Okay, decomposed by the decomposer, and they change them into simpler substance, return back to the soil, which we can call it fossil fuel. And this is for the dead plant, dead animal, any one of them. After a million years ago, their dead remains or remains of dead body will form a fossil fuel. Who can tell me some examples of the fossil fuel?
Maybe coal.
Cool, excellent. What else?
Fuel.
Okay. Oil and the natural gas. So coal, oil, and the natural gas. So first of all, the fossil fuel here, it's a fuel that formed over a million of years during a series of physical and chemical change to the organic substance of the dead plant and animal remains, and they will form the fossil fuel. The fossil fuel here, when I called it fuel, the word fuel means what? Means that anything burn to get thermal energy. Like this, we have, of course, the three types of fossil fuels, which are coal, oil, and the natural gas. First one, coal comes from the dead plant, especially the large trees. When, for example, imagine this is a forest from years ago or over a million years ago, and after all these plants die, what will happen? The decomposer will decompose their body into small pieces. What will happen after this? The dead remain will be under the earth, beneath the earth, according to the heat and the pressure from the sun over a million years ago. After heat and the pressure, what will happen? These remains will turn into coal, which is a source of fuel or a type of fuel, but we can call it a fossil fuel because it's formed from the fossil. From the fossil means remain of dead plant and animals. Okay, so coal come from plant, especially the large trees. What about oil? Who can tell me? Coal come from the dead plants, especially large trees. What about oil and the natural gas? What do you think? From plant or animal? Remains. Who can tell me? The marine. Okay, excellent. Animals, especially the marine. From the marine organism, which is the aquatic, which can live in water. So due to, okay, this is ocean, for example. It's look like a story. This is ocean, contain many marine organisms. After their death, the decomposer will decompose their body into small pieces to return back the nutrient into the soil. So what will happen? The dead remain of the marine will form like a layer, or it will buried under the layers of the soil. After many years, it will exposed to high temperature, high pressure from the sun. It will form another fossil fuel, which is oil, petroleum oil, and the natural gas. So the petroleum oil here, it's organic. Origin or the source which form the petroleum oil, it's a marine organism, the aquatic, which can live in the water. Natural gas, it's from the marine organism too. And maybe we will find them together or separated from each other, oil and the natural gas. But the composition of natural gas contain more than 90% of methane gas. So the methane gas represents the major component of natural gas, form more 90% of natural gas. Okay, thanks for you. We finished the curriculum. Congrats. Okay, do you have any question in this part?
No.
Okay, yes or no, Jana? Tell me.
No.
No, okay, and Lina?
No, thank you, teacher.
Okay, well done. So we finished the curriculum. Let's open المعاصر notebook. We have here some model exams. It's not like a trial exams in the whole curriculum. Let's open it. It's the page number 104. 104. Open it and let's discuss together about the questions of model exam number 1. And let's start by Jana or Lina. Who will start with me? We will discuss together. It's 104. Okay, well done. I'm waiting for you.
Okay,
Okay, you can start right now. And I want you to write the answers with me as we get used. Okay? Number 1.
The electron configuration of the following elements is with less than 4 electrons, except hydrogen.
Less than 4 electron, but hydrogen contain 1 electron only, so less than 4. We want to accept it ends in the outer level or outer shell with more than 4 electrons. Which one of them? Try to think about it. And Lina, you can share with us.
Phosphorus, because it's non-metal.
It's a non-metal. Excellent. So the non-metal, you told that its outer shell contain more than 4 electrons. And the hydrogen, for example, Juju, hydrogen is a non-metal gas too, but it's contain only 1 electron in its outer shell. Okay? But sodium, magnesium, they are sodium ends with 1 electron, magnesium 2 electrons. They are metals, contain less than 4 electrons in their outer shell. Great. Lulu, number 2.
The object whose mass is 2 kilogram and its speed is 3 meter per second has a kinetic energy equals
First of all, tell me the rule of kinetic energy to calculate.
It was half in mass and v squared.
Time v power 2 or v squared. Great, well done. So substitute with numbers. Half. What about the mass number here?
Half multiplied 2, it will be
It will be 1. Have to, it will be 1. Okay, what about the speed? Velocity? It's a 3, but we have here in the rule v power 2, so it will be 3 power 2. Means 3 times 3. 3 times 3 equal?
9.
So 1 times 9. Multiply 9, it will be 9 joules. Great, well done. Give reason, Jana. First one.
Teacher, is it joule or kilojoule?
Isn't what?
Is it joule or kilojoule?
No, we have here joule. Kinetic energy, potential energy, mechanical energy, work done, all of them, their unit is joule. Maybe in some question they will ask you to make it with the kilojoule. Okay, but here we don't have this. So in ordinary state, you will make it with joule until it asks you to convert it after you calculate it into kilojoule. If it asks you to convert. But here in this question, it doesn't ask us to convert it into kilojoule. So it will be joule. Okay, Lulu? Okay, Jana, number 1 in give reason questions.
Okay. The difference of the evaporation process from the boiling process. The evaporation the evaporation happens at any degree, but the boiling happens at 100 Celsius.
Great, well done. So the difference of evaporation process from the boiling process, that write it right now, all of you. The evaporation process, as Jana told us, it can happen or occur at any degree, at any temperature, while the boiling point, no, or boiling process, it happens in a special degree, which is 100 degrees Celsius. So this is the difference point between the two items. While they are similar it's a change from liquid state to gas state, okay? But here, only ask us about the difference. So write the difference only. After you finish writing, turn to number 2, Lina. Hala, we are in the last 10 minutes in our session today. We finished the last part of the last lesson in the curriculum, and we are right now in model exam number 1 in the Mu'asar assessment book. Okay, you can open the page and discuss with us.
I was like in the normal like meeting. I thought we had like a normal session. I didn't know there would be another teacher, another meeting.
Okay, but I put the link of our session today. Okay, never mind. You can return back to the record. You can watch the record again because we answered and explained the last lesson.
Okay.
Okay, never mind. I'll upload the record after our session directly, inshallah, today. Okay, yes, Lulu, you are with me right now. Lina.
Yeah. Okay, the relationship between bees and plant flowers is mutualism because both of them benefit from the other.
Great, well done. How can you explain this relationship, Lina? How can they get benefit from each other?
Bees use the pollen grain of the plant flowers, and at the same time, it transfer it to many other places that makes.
Okay, the bees first of all benefit because it extracts the nectar from the flower. Extract nectar from the flower, while the flower will benefit because the bee will transfer the pollen grain to another place or another flower to help in the reproduction process. Reproduction process here means make a new plant. Okay, so because both of them get benefit from each other, we can call this relationship as mutualism. Great, well done. Hala, can you share with us an answer number 3?
Yeah.
Yes, number 3.
Sorry. The electrical conductivity of acetic acid is less than the electrical conductivity of hydrochloric acid. Because the acetic acid is stronger than the hydrochloric acid.
No, the opposite one. Acetic acid is weaker than the hydrochloric acid. Okay, because the hydrochloric acid is a strong acid, while acetic acid, it's the vinegar, by the way. Acetic acid means vinegar, okay? It's a weak acid. And we differentiate between the strength of acid by, how can we differentiate the strong acid or it's a weak acid? By electric conductivity. If it's a good conductor of electricity, so it will be strong acid. If it doesn't conduct or bad conductor of electricity, it will be a weak acid. So the acetic acid, which is vinegar, is a weak acid, while hydrochloric acid, HCl, is a strong acid. So it's a good conductor of electricity too. Okay, Jana, can you answer number 4? So we will just say, because hydrochloric acid is a strong acid, while acetic acid is a weak acid. Just it. And the last question here, we explain it today. Something like it. We explained something like it, and you explained it before or took it before in unit 2. Okay, tell me.
The combustion burning on fuel in a car is applied by a conversion of energy because it contains chemical energy.
Excellent. Chemical energy, which type, Jana? Potential or kinetic?
What, teacher?
Potential. Great, well done. So, because, write with me, because when the fuel burns, its potential chemical energy changes into kinetic energy. Of course, it will help the car to move. So, because when fuel burns, I write it, okay? Because when fuel burns, its potential chemical energy changes to kinetic energy. Okay, Hala, if you finish writing this question, answer the next one. Number 1, complete.
Bromine is a liquid non-metal, while mercury is a liquid metal.
Great, well done. Liquid non-metal, while mercury is a liquid metal. Great, Lulu. Our lesson today. Limestone is, while marble is.
Limestone is a sedimentary rock,
Great.
while marble is a
Meta, MM. Marble M. MM, okay? Marble metamorphic, remember it. Metamorphic rock.
I was trying to remember its name.
MM. Directly remember with this password, MM. Marble metamorphic.
Okay.
Okay, Jana?
Okay. I was confused. Okay. How can each of the following be indicated? The danger of concentrated sulfuric acid. We can add sugar to it.
Yes.
Or we can
add sugar to it. When you add sugar to it, what will happen?
The carbon will flow from the sugar.
This means that the sugar will be churned or burned, right? So when we add sugar to it, the sugar will burn or churned. Okay, excellent, John. Write it. Okay, and we will stop at this question.